This screencast is about collinearity in a multiple linear regression model. Collinearity refers to a situation in which one independent variable is significantly linearly related to the other independent variables. Collinearity is the likely explanation when a coefficient value is counterintuitive. For example, you expected the coefficient to be positive, but it turned out to be negative in the fitted model. The F-test for overall usefulness of the model indicates a useful model, but none of the t-tests indicate a useful independent variable. When an independent variable is removed from the model, the coefficients of the remaining independent variables change drastically. Ideally, collinearity should be small, but there can be a trade-off between the ability to obtain a large adjusted R-squared and the amount of collinearity present. When using a model with significant collinearity, do not attempt to assign specific meaning to the model coefficients. Only predict with x values that follow the same pattern as the x values in the data set used to fit the model. Here is an example. Suppose you wish to predict the market value of a house based on the house's assessed value, square feet of living area, age expressed in years, and the land area expressed in fractions of an acre. Suppose further, when you fit the model, you obtain an R-square of 92%. But the coefficient of assessed value turns out to be 0.05, which seems too small to reflect the relationship between assessed values and market values. To investigate the problem, you fit a second model with assessed value as the dependent variable and the other independent variables from the original model as the independent variables for this second model. And the second model tests as useful with an R-square value of 85%. The conclusion is collinearity is present in this model. Square feet, age, and land area contain essentially the same information as does assessed value to predict market values. In fact, the assessor probably uses square feet, age, and land area to determine assessed value. We leave the example and state a general definition, a definition for variance inflation factor. For a multiple linear regression model, pick an independent variable, any one. Call it xj. We define the variance inflation factor associated with that xj as 1 divided by 1 minus rj squared, where rj squared is the coefficient of determination for a second regression model with xj as the dependent variable and all of the other original independent variables other than xj used as the predictor variables in the second model. We've moved to the next page. On this page there's a class exercise that would help you become familiar with the relationship between a coefficient of determination and a variance inflation factor. We have a working rule that relates independent variables and variance inflation factors. It says, if a variance inflation factor associated with a particular independent variable is greater than or equal to 5, then excessive collinearity exists in the model, and the independent variable xj should be considered for elimination from the model. Now, whether the independent variable is eliminated or not depends upon how much r squared adjusted you would be giving up if you eliminated that xj. At the top of this next page, we review the method of obtaining the Ifs. We suppose we're working with a multiple linear regression model where y is the dependent variable and we have these 8 independent variables. If we wish to obtain the variance inflation factor associated with the first independent variable, what we do is we create a second model in which x1 is the dependent variable, and all of the other original independent variables serve as independent variables in the second model. When we fit that second model, we obtain a coefficient of determination. That's the r1 squared. We plug that r1 squared in the expression for the variance inflation factor. So the variance inflation factor associated with the x1 independent variable in the original model is simply 1 divided by 1 minus r1 squared. In problem 2, a U-try, you are asked to describe the method to compute the value of the variance inflation factor associated with the second independent variable in the original multiple linear regression model. This completes this screencast on collinearity.